Alrighty, hello and good afternoon, everyone. As good as a afternoon as it could be. Let's see. Today is the last time we will ever be hanging out on a Monday on YouTube. This is the final week of class. So we only have four more days of classes. That is 4 lectures and 2 office hours. About a total of 12 hours of class time altogether. So it is going to be a full week. This summer session we kind of got into a rhythm where we take an exam and then there'd be 2 weeks later we take the next one. But coming off the coattails of exam 3, we are heading into the final exam, which will drop this week, and I'll have more to say about that in just a minute. So we've got some business things to go over before we start doing chemistry together. So a couple things. First off, I want to say. That okay, there we go. So first off, I want to say that lab quiz 11 is not yet available on Canvas, but I am posting this guy today. I doubt it's been on anybody's radar. I haven't received any communication or questions because the exam closed last night, so that's been first and foremost in everyone's mind. I'll be posting lab quiz 11 today. Second bit of news, and this chunk is actually good news. Homework 8, which I'm sure nobody has started thinking about yet because homework 7 is due tonight, but our final homework set, I've decided to give everybody a break. I am canceling this assignment with full credit. So you guys have all been busting your butt, working crazy hard this summer. So I wanted to give you all a kind of a send-off present the last week of class. So homework 8 is canceled, and you all just got 100% on it. So that is that. Now, so the final, we should spend a little bit of time talking about the final. Yeah. So the final. So the final exam, let's see. There we go. The final exam will open this Friday. So it opens just like all of our exams. 12 a.m. Friday. So this Friday is the 31st. You are welcome. And it closes normally the final closes on Sunday, or sorry, normally exams close Sunday evening, but I'm bumping this back. Its official due date and time is let's see, 11:59 p.m. on Monday. So a slightly larger window. You'll have one more day to study up and complete it. It closes on Monday. Okay, Prathana, excellent question. Excellent question. One of the things before answer that question, something that I think is important to note. So this Thursday, which is the 30th, is the last day of class. All right, so Thursday will be the last day that we hold lectures, office hours, etc. In the academic calendar for the Los Rios Community College District, the 5th of August is the last day of the summer session. Oops. World's tiniest eraser over here. All right, and then final grades are due for submission. So that's submission by me to the school. They're due on the 10th. Now, I usually don't I don't submit them the last day. I submit them as soon as all the grading is done. That doesn't necessarily mean that your grades will be visible on your transcript on the 10th. But that's the last day to submit. So then they become available soon thereafter. Okay, so Prathana, you had some questions about the chapters that are on the final. So let's talk about that business. Susan, I will double check and adjust the due date if needed. Okay. So let's take a look. Okay, so the final is cumulative. Now, the way kind of the exams have been structured up to this moment in time is each exam has been worth 30 points, right? And is focused on the most recent material, though to some extent there are some concepts that are just applicable throughout the whole of chemistry. But the focus has been each exam has been worth 30 points and has been focused on the new chapter. So when you think about exams 1 through 3, in exams 1 through 3 we covered chapters 1 through 8. All right, so this is the old stuff. All right, and so for the final, which is worth 50 points total. The final's worth 50 points total. 30 points will be new stuff, right? Just like every exam has been worth 30 points and is focused on the new material. I didn't want to slight the chapters that came after chapter 8. So 30 points will be the new stuff, and then 20 points will be the old stuff. All right, so the old stuff is everything that was covered on exam 3 and prior, and then with respect to the new stuff, how much new stuff we have partially depends upon the flow of lecture this week, but it will definitely, it will definitely include, let's see, definitely include Chapter 9, Chapter 10, plus, who knows, at this moment in time we've completed Chapter 10, so it'll at least have those two, and then how much more depends upon how lecture progresses this week. Now, I will be posting more information today on the I don't know the percentages yet of the exact percentages of the new stuff. It'll be at least or I should say it'll be approximately 50-50-ish for Chapter 9 and Chapter 10. There's going to be some other stuff sprinkled in there, but it will predominantly be Chapters 9 and 10 with some new stuff sprinkled in. But the stuff that we covered this week, because you have the least amount of time to study it, won't be heavily emphasized. I will have a post later today going up with the specific concepts from the old material that will make it on the exam, the percentage breakdowns. But for now, as far as the old stuff goes, here are the percentage breakdowns. So Chapter 3 will be represented, will be 6% of the final. Chapter 4 will be 4%. Chapter 5 will be 8% of the final. Chapter 6, also 8%. Oh wait, no, sorry. It's not Chapter 6. Chapter 7 is also 8%. And then Chapter 8 will be 14% of the final exam. So this material right here is all the old stuff, which together is worth 40% of your final exam. Right, the other 60 is the new stuff. One thing you may be wondering is right in here, where the heck is Chapter 6? Chapter 6, the answer is Chapter 6 isn't missing. Chapter 6 is everywhere. If you go back and look at what Chapter 6 was on, it was about stoichiometry. So every time you calculate a yield, you're doing Chapter 6. Every time you are converting from grams to moles, you're doing Chapter 6. Every time you're, calculating molecular weight, all that stuff was all Chapter 6. So Chapter 6 isn't missing, it's everywhere, but it's going to be peppered in with other problems. Okay, Kate, that is an excellent question that everybody has. And I'm so glad you asked, because it was actually my next, my very next slide. So the final will have 45 problems. And you will have 2 hours to complete them. And with that, you can expect, so you can totally expect the final exam to have a comparable difficulty to Exam 3. Um, I, I would totally so it will totally be about as hard. Um, yeah. So I would prepare for it as if you're going to face exam 3 again, because this will definitely be a challenge. Okay, let's see. Well, I appreciate you expressing that opinion. Well, here we're actually about to talk about exam 3, so let's actually dive into that. So let's talk about the third exam. So exam 3 was the most difficult exam we faced to date, or you faced to date, right? I didn't. Well, I mean, I did take it, but that's part of my writing process. So, exam 3. So, let's talk about the average here, and this was not unexpected. So the average. For the exam, I actually had to correct. There were a couple outlier scores. There were some students who stopped showing up to the class, but then showed up to take exam 3, where there's been this like gap of assignments, and then so I had to throw out some outliers. But the average, for exam 3 was a 60%. So definitely our lowest, but not unexpected. What I usually see when I teach these classes, especially in the summer session, is there's tends to be an aggregate fatigue, just because we're going at a breakneck speed, and in 2 months' time we've covered 4 months of material, and so the last exam tends to have a lower average. Reality is, though, this average is on par, if you can believe it or not, with the averages that I typically see for the third exam. So it's not particularly, it was a harder exam. We're at the end of the summer session. This is usually what happens. So this is the average for the exam. I guess I should specify that. That being said, if you look at the class average, all right. So what is the average total grade for the class at this point in time? The class average right now is an 80%, which is actually higher than normal. I don't actually. I looked back. Didn't look back at all the classes, but I was looking back at my summer session classes. I've never had a course with a class average of a B in the summer session. So you guys all are doing well. I know that after the exam, an exam where an average is 60%, morale is definitely going to be low. I know humans are definitely feeling defeated or discouraged at this moment in time, but I do want to remind you that as a collective, you guys are actually doing better than any other summer session that I've ever had. So I want to tell you that you are doing a good job, and you're actually setting a record at this point in time. So. Let's see. Okay, we've got a ton of questions. Carinza, the only thing that needs to be revised is I haven't graded the lab exercises for lab exercise 10, so those haven't been entered, and I haven't graded the free response for the lab quiz number 10, and also you should know. I know I sent a couple emails out, but not everybody asked about it. The lab quiz number 10, the professor who wrote it made the free response questions worth half of the quiz. So if you were distressed over a particularly low quiz score, the reality is half of those points haven't been assigned because I haven't gotten around to grading the free response questions. So that should help everybody else out. You see, Kate, I actually think the well, let's. No, not at all. I don't think that I think the average on exam 3 is an accurate reflection of the comprehension of the exam 3 material, so specifically chapters 7 and 8, which tend to be two of the harder chapters in the course. So I think it's comparing apples and oranges, because each exam tests for a different body of material, and usually things are tipping down for the harder material, and reality is you guys are having to do stoichiometry with solutions, with gas phase stuff. It's a challenge on a whole nother level. So it's typically what we see. Now, here's the thing, is I totally get it. I totally I'm used to at this moment in any course, but especially in a summer session, right? Because we're all burnt out. You guys have been working hard, and we're almost done. I'm used to being the kind of focal point and object of a lot of negative emotion at this moment in time, and here's what I do want to say, and this is just a word to the wise for moving forward. So here's the thing, and this is something that every student deals with after a hard exam, and every course as a group has to deal with after a test with a low average, because it means that everybody was struggling with this material. Here's the thing. Here's where you are right now. You have a 1 week left, right? We've got 4 classes left, and final exam opens Friday, closes Monday, and then the semester's done. I know that frustration is real, and I understand that, and I empathize that. I'm not so terribly old that I've forgotten what it feels like to be a student and stressing about grades and all that stuff. But here's the deal. It's there's only one way forward, right? There's only one way forward, and that's marching towards the final. So here's the deal. Like you saw, actually, right here, this stuff right in here. Oops. Chapter 7 and Chapter 8. This is exam 3 material. And it is worth 22% of the final, right? It's worth a significant chunk of the final exam, and this is material that, as a class, we've struggled with. And so, I kind of did. I woke up early this morning. By early, I mean like 5:30. And I took some time to go through the exam, look at not just the averages and the numbers and all that stuff, but look at the problems that were giving students the greatest degree of trouble, the problems that students were performing what's the word I'm looking for? the individual problems that had the lowest averages. Sorry, my computer's freezing. So give it 1 second while we boot up there. So I looked through exam 3. I found the problems that had the lowest averages, right? The ones that were giving you guys the most trouble. And rather than push forward into new lecture material, right now what I want to do is systematically work through the problems that were giving you the most trouble, not the exact problems. Obviously from the exam, but problems similar to them. Mostly because, I feel like it would be a better use of our time at this point to really tie up and tie down the material that you were facing on exam 3, because you will be facing it on the final. And so that's what we're gonna do. I'm gonna go through these systematically. Reality is we have 2 chapters left in the textbook. I doubt that if we weren't doing this, if we weren't taking this time to review, then we could definitely get through both of them, because they're not very heavy chapters. Like the acid base chapter was a heavy chapter, but the 2 chapters left aren't particularly heavy. However, I think it's worth our time to kind of go through the material that you all were struggling with, try to shore up that foundation, and if that means that there are fewer chapters coming, holy moly, no. Fewer chapters covered on the final, I think it'll be worth it. Okay, sorry, I fell way behind on all the comments in the thread because my secondary computer froze. Not the one I'm streaming from, but I have one on the side, so I can, because when I'm writing, it takes full screen on the device I stream from. So that computer froze, and I missed a bunch of comments. Let's see. Sorry, I'm just working my way through. Okay, so that's kind of our plan going forward. I mean, here's the reality, and this is just the way I write my exams. There are always going to be problems that you haven't seen specific examples, like where we haven't done that exact problem, but if you understand the concepts, the material that we've been covering, you'll be able to solve them. So there's always a gradient of problems where we've done exact ones like this, problems that are at a higher challenge level. And so you should expect to be surprised as you hit up each new exam, and that's just part of the mix. But we're gonna take some time. We're gonna go through these problems that were particularly challenging, and let's see where this goes. Hopefully it'll prove helpful. Okay. So here, let's do our first example. This is an example based on Chapter 8 material. So we'll start here. All right. So aqueous silver perthana. Well, to be honest, okay. Let's start doing some examples. All right, so aqueous silver 1 nitrate reacts. Okay, guys, here's the deal. Half of the class isn't failing when the average for your total grade is 80%. That's just the reality. Half of you guys aren't failing. In fact, I can tell you right now that, let's see, that only 9% of the class isn't passing right now. All right? That's just the reality. That is ridiculous for a STEM class to have 91% of the class above passing right now. So here's the deal. You guys can continue to vent, or we can move forward in a positive direction, get some reps in, practice some chemistry, because ready or not, the finals come in this Friday, okay? So let's adopt that mindset and move forward, okay? All right. We do have material to move through in lecture. We'll have a lot more opportunity in office hours to get into stuff and discuss stuff, but I felt like we would need to talk about things because of how the third exam went. But here's the reality. A 60% on a chemistry exam is not strange. It just isn't. This material is hard, as you know. So let's move forward. All right. Let's move forward by solving this problem. We can, again, if you want to talk about stuff at further length, that is part of what office hours is for, but lecture is predominantly for instruction. And we've spent the first, 34 minutes. Kate, that comment totally did get lost. I did not see that at all. This week I will correct the prereq exam. And that is my promise to you. Alright, so let's see. Silver nitrate reacts with aqueous sodium chloride to produce let's see there we go, solid silver 1 chloride and aqueous let's see let's see, solid silver nitrate, aqueous sodium nitrate. All right. So let's see. We are told that we have 44.00 milliliters of silver 1 nitrate. Mixed with 32 milliliters of sodium chloride. We're also told that each solution never spelled has with an E before, has a concentration of 0.204 molar. All right, and then we're asked three things, which I'm going to need a new slide. First, we are asked, what is the stoichiometric coefficient of silver 1 chloride? All right, in the balanced chemical equation. Number 2, we're asked how many grams of silver nitrate, grams of silver chloride were produced and then third, we're asked to determine the molarity of the solution of silver nitrate. Sorry. Let's see, determine the molarity of the solution of, hang on. Of, sorry, not silver nitrate, sodium. Sodium nitrate. Okay, so here's the deal. First things first. In Canvas, I can't really ask you to write a balanced chemical equation because all the symbols and stuff like that, it just wouldn't make sense. There'd be no way I could actually do that. But when I ask you what is the stoichiometric coefficient of any given species, this is just testing to see, do you know how to balance this situation? All right, so let's go ahead and dive in to that step one problem. All right, so so we have a reaction where we have silver 1, right? So silver is a transition metal, charge of positive 1, and nitrate together. And then our other product is sodium, which we get its charge from the periodic table, and chloride. We get chloride's charge from the periodic table as well. So silver nitrate is going to combine in a 1-to-1 ratio. Oops. And sodium chloride also combines in a 1-to-1 ratio. All right, and so those are our two reactants. Our products are solid silver chloride, again 1-to-1 ratio because it's positive 1 and negative 1 coming together. Same with sodium nitrate, NaNO3. And this is aqueous. All right, so we've written out our reactants and our products. Now we have to balance, right? We've got silver, nitrogen, oxygen, sodium, and chlorine. Silver, nitrogen, oxygen, sodium, and chlorine. Now, on our reactant side, we have 1 silver, 1 nitrogen, 3 oxygen, 1 sodium, and 1 chlorine. On our product side, we have 1 silver, 1 nitrogen, 3 oxygen, 1 sodium, and 1 chlorine. So it turns out this chemical equation is already balanced. This chemical equation is already balanced. So the molar ratio between all of our reactants and products are all 1-to-1-to-1. Therefore, when problem 1 asks, the first question, what is the stoichiometric coefficient of silver chloride? The answer is just simply 1. I love when it happens too. In fact, I love when it happens so much that I put it on an exam for all of you. Okay, so let's look at part number 2. How many grams of silver chloride were produced in this reaction? Whoops. So we are being, whoa, that's green. Let's go back to black. We're being asked to find the grams of silver chloride, and what we're given here we go. We are given the milliliters of our two solutions. We're told 44.00 milliliters of silver nitrate, and we're told that we have 32.00 milliliters of sodium chloride. And we're told that the solution of each had a concentration of 2.4 molar. Sorry, 0.204 molar. All right, is the concentration on both the solutions that we're mixing together. All right, So all this is right here is we're being asked to find a theoretical yield. All right, this is definitely something we've done before. What we need to do is we need to take our two initial quantities, our solution of silver nitrate, our solution of sodium chloride. We need to use each to calculate how many grams could be produced, right? How many grams of silver chloride could be produced by each. And then, whichever one is lower, that'll be the theoretical yield, because it comes from the limiting reagent. So let's go ahead and start with silver nitrate. 0.204. Now, molarity, remember, is moles of solute, which is silver nitrate here, over liters of solution times our volume. Now, you'll notice that our volume here is in milliliters. You have to convert from milliliters to liters. So 1 milliliter is 10 to the negative third liters. So in order to get rid of this denominator here, we have to convert our 44 milliliters to liters. So when you do, it comes out to be 0.04400 liters. Liters cancel. And then, so now we have moles of silver nitrate. Next, we need to convert from moles of silver nitrate to moles of silver chloride. And the ratio from the balanced chemical equation is a 1-to-1 mole ratio. So now we have moles of silver chloride. The final step, the final unit conversion here, is moles of silver chloride to grams of silver chloride. And I know silver's like 107. Um, 107 point something. There we go. Silver is 107.87. And chloride is 35.45. When you add these together, let's see, 107.87 plus 35.45. This adds to 143.32. Grams of silver chloride to moles. So now moles of silver chloride cancel moles of silver chloride, and we are ready to crunch our numbers. So we've got 0.204 times 0.044 times 143.32. All right, so this comes out to be, let's see, sticking with 3 sig figs here. This comes out to be 1.29 grams of silver chloride. Now, we don't know if that is our theoretical yield, because we haven't yet done this calculation with our second reactant, sodium chloride. So, we start with 0.204, again, breaking up the unit of molarity, moles of sodium chloride, which is our solute, over liters of solution. Now, we have to convert our milliliters to liters again, right? We've got to convert 32 milliliters to liters. Comes out to be 0.03200 liters. So our volume units cancel. So, we'll get there. We'll get there. Right now we're figuring out our theoretical yield. So let's see. So we need to convert from moles of sodium chloride to moles of silver chloride. And again, we have a 1-to-1 mole ratio. Now we have moles of silver chloride. Our last unit conversion is to convert our moles of silver chloride to grams. And with that final unit conversion, we will be able to determine our theoretical yield. We just have to crunch our numbers first. Times 0.03200 times 1 divided by 1 times 143.32. All right, so here let's see, 3 sig fig, so we got to go 0.936 grams of silver chloride. Now, when you are determining your theoretical yield in a limiting reactant scenario, the theoretical yield will be the smaller of the two values calculated. So this is the mass of silver chloride produced in this scenario. All right. So that is part 2. We've determined our theoretical yield of silver chloride. Finally, the last part of this problem. There we go. We're asked to determine the molarity of the aqueous sol produced. All right, so finally, we have to determine the molarity of sodium nitrate. All right, And again, we're still given the same starting stuff. What we're told is that we have 0.204 molar concentrations initially of each what's the thing of each reactant, that very hard word, and then we're told initial volumes, or the volume of each solution that we mix together. Where's the one? There we go, 32. Oh shoot, what did I do? All right. So we're asked to find the molarity of sodium nitrate. So let's think about this. If we need to find the molarity of sodium nitrate, well, there's an equation for molarity, right? Molarity is equal to moles of solute over liters of solution. Right now, with this, our numerator, we can find our moles of solute from our limiting reactant, right? This here is just stoichiometry. Right? This is just stoichiometry to find our numerator for this expression. Now for our denominator, what is the volume of this solution? Well, we mixed two solutions together, right? 44.00 milliliters of one solution, and we mixed it with 32.00 milliliters of the other. So combined, that adds to 76.00 milliliters, or if you want to convert it to liters, and we do, because we are calculating a molarity, comes out to be 0.07600 liters. So that is our denominator. Now we just have to find the moles of sodium nitrate produced. Ah. Kate, great question. You are welcome. You're very, very welcome. Thank you for saying thank you. I appreciate that. Okay. Okay, so we've got our denominator. We know how to get our numerator. Let's go about doing that. So we know that we have 0.204 moles of our limiting reactant, which in this case is sodium chloride, per liter. Kate, you're welcome as well, and thank you for saying thank you. We're going to get a lot of thank you reciprocation today, from me at least. All right. We our volume of sodium chloride was 32 milliliters, right, or 0.03200 liters. So our volume cancels. And then finally, we don't need to know grams of sodium nitrate, we just need to know moles. And so we only have one more unit conversion left. That is 1/1. And now we're good to crunch our numbers for our numerator. We have 0.204 times 0.03200 times 1 divided by 1. So our numerator will have 0.00, let's see, 3 sig figs, 653 moles of sodium nitrate. All right, so now that we know the numerator and the denominator, we're good to calculate our molarity. Let's see, well, I just said we know the denominator, but I can't remember what was back one slide. There we go. All right, that is 76 milliliters, or 0.07600 liters. All right, so let's see. So we have 0.00653 divided by 0.076. All right, and this is equal to, keeping 3 sig figs, 0.0859 molar of sodium nitrate. All right, so that is the answer for step 3. All right. All right. So that is shoot, that's our first one. Okay. Parts A, B, and C. Okay, so let's jump to another one. This is still Chapter 8 material, the stoichiometry problems. Everybody struggled with by and large, so there are quite a few of these here. So let's give this one a whirl. So we have aqueous. Whoa, hang on. Let's open a new slide. Um, aqueous phosphoric acid reacting with, let's see. On the product side, hang on. So the short answer to your question is yes. But let's do it in office hours just because I don't have one like that prepared. I can totally make one like that for office hours, but we're on a little bit of a crunch here with lecture. Actually, I'm looking at our time. We're like out. Let me set this problem up, and then we'll come back to it, resume it on Tuesday, on tomorrow. Yeah, totally. Office hours will give me a chance to cook one up, but I don't have one locked and loaded at the moment. Okay, let's see. So, phosphoric acid reacts with sodium hydroxide, which is aqueous, to produce liquid water and aqueous sodium phosphate. All right, and we're told that 25.00 milliliters of 1.07 molar phosphoric acid 25 milliliters are mixed with, let's see, are mixed with 35.00 milliliters of 2.08 molar sodium hydroxide. And then we're told the percent yield of water for this reaction was 98.0%. And then we're asked again three things. The first being, what is the stoichiometric coefficient of water? Number two, we are asked to find the theoretical yield of water in grams. And then third and finally, we are asked what is the actual yield. Of water in grams. All right, so very similar setup to what we did, not exactly the same, but a very similar problem to the one that we solved right before this one in lecture. We will pick up tomorrow by working this problem, so take a crack at it, see how it goes, see if you can maybe make some progress, and we'll pick up our discussion tomorrow. Susan, totally. And something to keep in mind, the summer session, even though Thursday is our last day of class, the summer session actually runs through August 5th. So if I'm not opposed to pushing the due date for it even beyond the last day of class, just to give everybody enough room to breathe. Obviously, the last chance to ask me questions will be office hours Tuesday, office hours Thursday, but I definitely want to give you all enough room to breathe. Let's see, I was not given the percent yield. Yep, some problems are different. Oh, you all are welcome. You know I'm pulling for you guys. You've been a fantastic class. I really enjoy our time together. I know it's always rough when there's an exam that's low, and I mean, and I think part of the thing too is like I know there are professors out there who like relish the situation, but I don't. I really do want everybody to do well, and I'm pulling for you, and we're gonna give this all our best go together. Cool. Okay, so I will. I'll see you same time, same place tomorrow. Unless unless I don't get out of bed. I totally will. We're gonna rock it all week long. You're well. Yeah, dude. Brianna, you and I both exam 3 made me sad as well. But we'll party all week. You guys will take your final, and then you'll be free. Catch you on the flip side.